The major components are now in place at the 8 Flags Energy site. Connecting these components together is a key step to completing the combined heat and power plant.
Well, we're standing next to the boiler, and what we have here is the pieces came in modules. So what we had to do when they got here is weld the modules together. So each one of these has a joint that were welded together here on site. This piece here is the boiler. It's a RenTech boiler, which would provide up to 200,000 pounds per hour. This unit here is the Economizer. And then you have a superheater section. And then you have 3 sections of ductwork that were all brought here by truck, and then each flange section had to be welded out. So here's one of the joints. The boiler came as a separate unit than the superheater. So this was one of the joints that we had to field weld right here. This one is the expansion joint right here. And then these are the field welds. So this is the mud drum here. I mean, this essentially is the boiler. Full of tubes, heats up. It's filled with boiler feed water, and this is what produces all the steam. Up top is your steam drum.
With the boiler components connected, the next step is installing and connecting the instrumentation needed to operate and monitor the boiler system.
What we're standing next to here is some of the instruments that we've started to mount. This particular area here is for the Herzig, the superheater. So you've got temperature indicators, pressure indicators, and Miller Electric's just started wiring these up. So what you'll have, this information from here will be sent back to the central control system, which will then be sent to the operator in the control building's screen. So he'll be able to monitor temperatures, pressures from this screen in the control building. This is the duct burner skid. It'll be fed by a 6-inch natural gas line, and then from here it runs over to the duct burner on the boiler. So the basic process here is Rayonier is going to take the steam that this produces on just normal operation of the turbine, and if Rayonier is normally operating, they're just going to take a smaller amount of steam. But if for some reason Rayonier needs an increased volume of steam, more than just the turbine exhaust air, this will fire up. It'll fire the duct burners, which will create that additional volume of steam to feed whatever Rayonier's needs are at that time.